Hi everyone, so welcome back to my channel Mathematic Girls Swati 3226. So as you have already seen the title of this particular video, so I'm going to cover all the formulas. Okay, and I'm keeping in mind the board exam is of course coming, so I have prepared this particular video based on that only. So yes, if you are if you're not prepared, if you think that you're not very well prepared, at least watch this video completely before you go for the your exam. So this will be very very helpful, because in this particular video I'm going to cover uh, all the possible formulas, so that is going to be very very helpful for you. Okay, so let's start with the first formula. And of course, let me tell you that this is one part. Second part I'm going to upload soon, where I'm going to cover the next part. So here in this particular video, I'm going to cover only the list of algebra math formulas for, of course, class 10. So first formula that I'm going to cover is, of course, algebraic identities. Okay, so there are 19 formulas which I'm going to write on, and all the formulas are very, very important. So let us start with the first formula, a very basic and a very obvious, a plus b whole square. So we all know the formula is a square plus 2ab plus b square. Remember, formulas we use to just make our questions simpler, to take lesser time. So that is what I'm just doing here, that I'm directly going to write down the formulas. I'm not going to explain how the formulas have come. For that, if you want me to explain the formulas, I'll make another video for that. The next is a minus b whole square. So a minus b whole square is similar to this, with just one sign change. It will become a square minus 2ab plus b square. Let's go to the next formula. That is a plus b into a minus b. This is also a very famous formula. A plus b into a minus b, and the formula is a square minus b square. Next, the fourth formula. So this is a very important formula again, not very common, but yes, you can use this formula if you'll come across such form. So x plus a into x plus b, right? So in this one, you have to simply use the formula of x square plus a plus b. So x square plus a plus b times x plus a into b. So for this particular formula, I'm also going to use, I'm going to take one example just to make you understand. So here you can see that x is same, right? So for example, I'm writing x plus 5, where a is 5, and then x plus 2. Then what is the value of for this? Of course, you can use here the distributive property, but like if you use the formula, then you'll get the answer just in one step. So it will become x square plus a plus b. What is a? 5. What is b? 2. 5 plus 2 is 7. So 7x plus a into b. What is 5 times 2? 10. That's the answer. If you don't know the formula, you can also do like this: x into x plus 2, and then plus 5 into x plus 2. Then of course you can see that you will be taking more time as compared to someone who knows this formula, which is this x square plus a plus b into x plus ab. So yeah, you can see you'll get the same answer: x square plus x into 2, that is 2x, 5 into x, that is 5x, and then plus 5 into 2 is 10, and that will become x squared plus 7x plus 10. So you can see we have got the same answer. All right, let's go to the next question, next formula, which is formula number 5. So it's like the same formula with a different sign. Okay, so here I'm going to write down x plus a into x minus b. So first of all, let me tell you that x square, and then like the other part is going to be similar. It's just we are going to have the like the sign change. That's it. So this will become x square plus, here this will become a minus b times x, and then it will be plus, instead of plus here it will be minus a into b. So this is the formula. Okay, let's go to the next one. So sixth one is x minus a into x plus b. So now see, we had the first case where we had the plus plus. Second case where we have the plus minus. Third case where we have minus and plus. So x minus a into x plus b. So this will become simply x squared. And then here, just to make it simpler, I'll be using plus sign outside. But instead of a minus b, it will become b minus a times x. Okay, so this is b minus a times x and then minus into b as it is. Minus a into b. So this is the formula. This is the sixth formula. Let's go to the seventh formula. So I'm just going to use a different color. Now I'll have both the signs, negative. Like the first case, exactly the opposite of the first case. It was x plus a into x plus b. Now we have x minus a into x minus b. So this will simply become x squared minus a plus b times x plus a times b. That is our seventh formula. So we have covered all the four possibilities. Now let's go to the cube. So a plus b whole cube. So a plus b whole cube, we have the first formula that is going to be a plus a cube plus b cube plus 3 times ab in bracket a plus b. This is our a plus b whole cube. Again, a very important formula like a plus b whole square. Now next we have a minus b whole cube. So let's write out a minus b whole cube. So this will become same formula with the negative sign. So a cube minus b cube minus 3ab into a minus b. This is our a plus b whole cube and a minus b whole cube. Now let's go to the next formula, which is x plus y plus z whole square. So this formula will be, this is a very important formula again. This will become x squared plus y squared plus z squared plus 2xy in a sequence. You can remember xy, yz and zx. That's it. So 2xy plus 2yz plus 2zx. Remember, if you write down zx or xz, it's the same thing because of the commutative property. So yeah. Okay. Now let's go to the next formula, which is the 11th formula. Here also I'm going to write down, the sign difference. Of course, the second case is going to be x plus y minus z whole square. Next case will be x minus y plus z whole square. And the third case will be x minus y minus z whole square. I just want to tell you here one thing, that if you know this formula, then you can easily write down the formulas for these other three cases on your own, because that is going to be very simple. But like if you just want to understand how exactly I can do this, I'll let you know. So just use this formula only. So it is x squared plus y squared plus, it says minus z square, right? What is minus z square? It will be z square only, plus 2xy, right? Plus 2yz, but here it's minus z, so that will become minus 2yz, right? And then plus 2zx, but because we have minus, it will become minus 2zx. So is it not very simple? If you just know this formula, then all the other formulas you can derive on your own. Next case will be, let's take minus here, so x minus y plus z whole square. So this will become again same, x square plus minus y square, but minus square will become plus, so it is just y square, z square as it is, plus 2x into y, but y is negative, so it will become minus, because plus into minus is minus, so it's minus 2xy. Then plus 2 into y into z, but y is minus, so minus 2yz, and then of course plus 2xz as it is. Now let's take the fourth case where I'm going to take everything negative. So it's x minus y minus z whole square. So what this will become, x square as it is, plus minus y square will become y square only, plus minus z square also becomes z square. And then plus 2 into x into y, but because we have minus sign over there, so it's minus 2xy. Then plus 2 into minus y into minus z, but minus y into minus z is plus z already, and plus into plus is plus, so it is going to be just plus 2yz. And the last case is minus, of course, because here we have 2 into minus z into x, so that will become minus 2 zx or xz, anything that you want to write. Okay. Okay, let's go to the next one, which is the 14th number formula. This is also a very important formula, and it simply says when you have x cube plus y cube plus z cube minus 3xyz minus 3xyz. So when we have x cube plus y cube plus z cube minus 3xyz, then we have a formula for this, which is x plus y plus z times x square plus y square plus z square. Okay, one second. X square plus y square plus z square minus xy minus yz minus zx. This is the formula, and this is, again, I'm telling you, it is a very, very important formula. Remember, there is a special case in this particular question, and that special case is if x plus y plus z will be equal to 0. That is the given condition. Then remember, it will simply imply that x cube plus y cube plus z cube will be equal to 3xyz. So the formula will become this, and it's very obvious. Why? Because see, if you are getting x plus y plus z is 0, that means this part is 0, and if this part is 0, so 0 multiplied by anything will be 0 only. So what are we getting? We are getting x cube plus y cube plus z cube minus 3xyz will be equal to 0. So of course you can send the minus 3xyz to the other side, and that will become your uh, plus 3xyz. So that's the formula. That's the special case. So I'll just mark it in a different color. So this is a special case of this particular formula, and many a times this question has come where, like the condition is given as x plus y plus z is 0. Next we have, this is a very rare formula. Normally we don't use it, but still I'm just covering all the formulas here. So I'm just going to cover x square plus y square as well. So first of all, you can also say that x square plus y square is nothing but x plus y whole square, and then minus 2xy. This is actually the formula, or you can say the conversion, shifting of the formulas from the first one. That was nothing but x plus y whole square. So x plus y whole square is x square plus y square plus 2xy, right? So from here you can see that what is x square plus y square? Is it not x plus y whole square minus 2xy? So from this only I have got this. Or there can be one more formula, which is x minus y whole square plus 2xy. This is the shifting of the second formula, which was x minus y whole square. Or there is one more formula for this, which is a very rare one, which we normally don't use, and that is nothing but 12 times in bracket x plus y whole square plus x minus y whole square plus x minus y whole square. This is the formula. So just remember these three formulas. Whatever conditions are given, you can just make use of this. For example, if the condition is given, for example, if you don't know what is the value of x times y, right, then you can't use this formula. And suppose the question is find x square plus y square. If x plus y is given and x minus y is given, then of course this formula will be very, very helpful to you, right? Okay, now let's go to the 16th formula, formula number 16. So formula number 16 says when we have x plus a times x plus b times x plus c, then this will be equal to x cube plus a plus b plus c times x square plus ab plus bc plus ca into x, ab plus bc plus ca times x plus simply a into b into c. That's it. A into b into c. This is the formula. This is the formula for x plus a times x plus b times x plus c. Now let's go to the 17th formula. So in the 17th formula, we have x. There are basically two formulas, like in form of cubes. So first we already covered, which was a plus b whole cube. Now here we are going to cover a cube plus b cube. I'm just writing this as x cube plus y cube. So x cube plus y cube will simply become x plus y times x square minus xy plus y square. And there is one more formula, which is x cube minus y cube, which is x minus y times x square plus xy plus y square. So this is the formula. Next, and the last formula that we are going to cover, the 19th formula. And again, I would say that this is a very rare formula that we use, and this is x square plus y square plus z square minus xy minus yz minus zx. So this is simply going to be half times, in bracket we have x minus y whole square plus y minus z whole square plus z minus x whole square. Remember, if you think that, like what's the need to remember all these formulas, trust me, these formulas are going to be very, very helpful in your exams if you know the formulas, because sometimes, you will be getting questions where you have to find out these things with these given informations directly. So if you'll know the formula, you will get the answer very quickly. All right. Okay, so this is something like, of course, from the algebraic identities. Now next I'm going to cover the quadratic formula. So let's go to the quadratic formula. Okay, so I'm reminding you that I'm just making this formula video for you, so that you can just have a look at it before your exams. Okay, so that would be your quick revision. So next is quadratic formula. So first of all, before we start with the quadratic formula, let us first understand that what is the standard form of a quadratic equation. So the standard form of a quadratic equation is ax square plus bx plus c equals 0. This is our standard form. Now, there are, like we talk about the roots of a quadratic equation. So let us take alpha and beta are the roots of this, equation, you can say. All right. Now, suppose alpha and beta are the roots of this equation. So we can just write down different cases. Okay. There is one more thing about a quadratic equation, that we find out the discriminant as well. So discriminant symbol we use using triangle. So discriminant formula is nothing but b square minus 4ac. This is how we find out the discriminant. Now there are certain conditions on whether the roots are going to be real, distinct, every single, like every other cases. So that is why we will have three conditions. First is when the discriminant is strictly greater than 0. So if the discriminant is strictly greater than 0. What is the meaning of discriminant? I have already written over here, which is b square minus 4ac, right? So if the discriminant is strictly greater than 0, then the quadratic equation will have distinct real roots. So I'm just writing it like this. Simply, it implies that it will have two distinct meaning different. So two distinct real roots. Second case, first case is done where the discriminant is strictly greater than 0. Next case is when the discriminant is strictly lesser than 0. So if the discriminant is strictly lesser than 0, then that will simply imply that it will have two imaginary roots. Imaginary imaginary meaning that you will have the roots containing I. Okay. So two imaginary roots. The third case is that if the discriminant is exactly equal to 0. So you are going to have only these three cases there will be no other case. It can be either less than 0, it can be either greater than 0, or it will be equal to 0, right? So in that case, we will have two equal real roots. Unlike the first one, right? In the first case, we had the two distinct real roots. Here, again, we'll have real roots, but they're going to be equal, not different. So we'll have two equal real roots. Now, just want to tell you here one more thing, that when we have the quadratic equation given, then there are two ways to find out the roots of the equation. The first way is to do the middle term split. Okay, the first way is to do the middle term split. And of course, if you want to understand how exactly do we do the middle term split, please let me know in the comment section. I'll make a separate video for that. And I'm going to make you understand this middle term split in such a way that you will understand it very properly and there will be no doubt. Earlier, when I started understanding the, solving the quadratic equation using middle term split, I used to find it so difficult. But I, somehow I understood this, and then I practiced a lot of questions, and then now it's very, very clear. Second method is by using the quadratic formula. So you will directly get the roots if you use the quadratic formula, and this quadratic formula is very simple. We just have to make use of the discriminant. Okay, so that will simply give you that x will be equal to minus b plus minus. So for one it is plus, and for the other root it is going to be minus. So I'm just writing it together. So minus b plus minus root over b square minus 4ac. So you can notice here that inside the root or under the root I have just written the discriminant formula, which I have written here, and then upon 2a. So that's the formula. All right, so this is about the quadratic equation. Now let's go to the progression. I hope you understand from the word progression, I'm talking about the arithmetic progression. So in arithmetic progression, we have few formulas that you should know. So let's start with the first formula, which is how to find out the nth term. So to find the nth term, we have the formula an will be given by a plus n minus 1 into d. I'm just going to tell you where what is what. An is of course the nth term. A is here the first term. That in a sequence, what is the first term given? N is here the number of terms. How many terms are there? And D here is the common difference. And how do we find out the common difference? By just subtracting the second term minus the first term, or third minus the second, or fourth minus the third, and so on. Okay. So D is our common term. So this is the formula to find out the nth term. Now let's find out the formula to find out the sum of the nth term. So to find out the sum of nth term, we have the formula. Let me just change the color. So that will be equal to Sn, which we write down as sum of the nth term as Sn, will be equal to a plus n by n by 2. Just remove this. Sn will be equal to n by 2 in bracket 2a plus n minus 1 into d. Where of course I don't need to write down again the same thing. N is the number of terms, a is the first term, and again n is the number of terms, and d is the common difference. Next, in progression formula, we have also the geometric progression, right? So in geometric progression also we have few formulas. So let's write down how to find out the nth term in a geometric sequence. So if you want to understand the AP and GP in detail, please let me know in the comment section again. I'll make a separate video on AP and GP topic, okay? Here I'm just going to cover the formula. So nth term of a geometric progression. Geometric progression, how exactly can we find out that? So we are simply going to use a formula for that. The symbol is same, it's AN. So I'll write down AN is equal to, it will become A times R raised to n minus 1. So A times R raised to n minus 1, where A is again the same thing, the first term. R is here then a different thing, so I'll just write down common ratio. How exactly do we find out the common ratio? So unlike common difference, we were finding the common difference by doing second term minus first term. It will become second term divided by the first term, or third term divided by the second term, like that. Okay, so this is how we can find out the nth term of the geometric progression. Same way, we also have like sum of the nth term. So this is going to be sum of nth term of a geometric progression. So how exactly do we find out the sum of the nth term of a geometric progression? We have here two cases. First is when we have to find out the sum of the n terms, and second is we have when we have to find out the sum of the infinite terms. So for n terms, we have the formula Sn is equal to a times 1 minus r raised to n, and then divided by 1 minus r. So this is the formula to find out the sum of the nth term of a, like sum of n terms of a geometric sequence, where there is one more condition, that r can never be equal to 1. Because if r will be equal to 1, then the denominator will become 0, and which is not possible, because anything divided by 0 is undefined. Next and the last one, that is sum of the infinite terms. When you will have infinite terms, then how can you find out the sum of infinite terms in a, here it was fixed n number of terms. Instead of doing nth, it will be sum of n terms. So the next is sum of infinite terms of geometric sequence. So this is going to be, there is another formula for that. So I'll just use the same symbol for this, which is Sn only, and that will become a into 1 minus a divided by 1 minus r. This is how we can find out the sum of the infinite terms of a geometric sequence, where a is again the first term and r is again the common ratio only. And that is it for today. This is part one. I'm going to cover the rest formulas in the second part of the video. I hope you understood all these formulas, and make sure you learn all these formulas before your exams. Okay, it will be very, very helpful. And yeah, that's it. Thank you so much for watching the video. If you have watched till here, that means a lot. And yeah, if you are new to my channel, and if you have not subscribed, don't forget to subscribe to the channel. Thank you so much.